We've looked at two types of functions. Sometimes we get confused with them. So we've seen reciprocals, and then we've also talked about inverses a little bit. And my pad got unplugged. There we go. So that was horrible. Oops. So reciprocals, if we recall, say the reciprocal of sine of x would be 1 over sine of x, which is different from an inverse. I just spelled different wrong. So the inverse would be the sine to the negative 1 of x. So this is not the same as the reciprocal functions. We're going to see a little bit why today. So we're going to start with, and this was on our the last partner quiz we had done. If we start with sine of theta is equal to y, what is theta?
The inverse sine y.
So what is the theta though? What does that symbol represent?
An angle.
It's an angle. And then our y is just, in this case, it's a proportion from our unit circle. This is technically y over 1, where 1 is our radius. So our input for this is our angle, and then our output, or what we get from the function, is the proportion. I'm also going to quickly sketch this guy. That's going to be... So we know sine starts at 0, and then it goes up to 1 at pi over 2, back down to 0, negative 1 to 0. So this is 1 period. And I continue the graph. And then it'll follow the pattern over here. How can we test if a graph is a function?
Horizontal line test.
Not horizontal.
Or vertical line test. Sorry.
So testing if it's a function is vertical. I need to not do it that way. So if it's vertical, if we do the vertical line test and it doesn't pass through 2 points ever, it is a function. We've talked about how sine is a function before. How can I test if it's a one-to-one function?
Horizontal and vertical.
Horizontal. So it has to be horizontal and vertical to be a one-to-one function. So if we look at sine,
which it is not.
It is not one-to-one, which we can explain from the unit circle because of what reason? What kind of function is sine? Starts with
repeating.
a p. It's a repeating or it's a periodic. Yep. So I have 1 multiple times, I have negative 1 multiple times, and I will always keep repeating. With one-to-one functions, those are the only times we can actually have an inverse function. So sine itself does not have an inverse function. We have to restrict the domain of sine to be able to get an inverse function. I'm going to go label these. This is going to be pi. This is 3 pi over 2. That's not necessary. This is negative pi over 2. This is negative pi. So normally the domain for sine is in negative infinity to infinity. But if we want to have an inverse function, we have to restrict our domain In this case, we have -1 as our low value of our range and a 1 as our ceiling. So if we wanted to cover every single value, I would only be looking at -pi/2 to pi/2. So I'm going to restrict my domain to be -pi/2 to pi/2. And I'm going to redraw this. So the new graph we're looking at is just going to be like so. It's just going to be essentially one period. That was horrible. So this is the only graph we now care about for sine of x, and this is why, like in the past, I've been like, yeah, just draw one period, that's fine. Because normally we only do, well, actually this is half of a period. We normally only do a small portion of the graph. I'm also going to draw a quick table. So for our x's and y's, I'm going to go through this one real quick. We have 5 values we care about, which are -pi/2, which is -1. We also care about -pi/4, 0, pi/4, and pi/2. Does anyone recall the value for sine at pi/4? I'm assuming no. So for sine at pi/4, it's √2/2. So at -pi/4 will be the same. And then we have 0 and +1. Okay. For inverse functions, we simply take the sine inverse of both sides. So I'd have theta is equal to sine inverse of y. So what is the input for the sine inverse function? So our y is our input, right? So our input for sine inverse is actually the proportion. And then our output is now the angle. So if I were to go graph this, I'm going to first make a table. Thanks. My inputs are now going to be my y's instead of my x's. My output will be the theta, which is the x. And I'm really just going to copy exactly what I see. So I have -1. No, this should be a negative √2/2, 0, √2/2, and 1. And then I'm just switching my input and my output, so -1 is going to be -pi/2. This will be -pi/4. We'll have 0.
pi/4 and pi/2.
Yep. And then my sketch isn't going to be the best, but if you were to do this in a calculator, it will mirror perfectly about the line y equals x. So I'm going to start, this is going to be -1. I'm going to switch my axes for this. Here's 1. This is going to be my -√2/2. This is my √2/2, and then my zeros. So at -1, I'm at negative pi over 2. At negative root 2 over 2, which I should label, I'm at pi over 4. Then I go to 0. Then I go to pi over 4, and then back to pi over 2. So if it's hard to see since I'm sketching this, I can pull it up actually on, because I have the calculator app installed. So I'm going to pull that up super quick. It always takes forever to load though. While that's finishing up, in this case, so our input was the proportion, our output was the angle. I didn't write the word output. Our domain for sine inverse is our inputs, which is -1 to 1. So it just switches the domain and range. And then our range, well, it has to be restricted, is going to be from negative pi over 2 to pi over 2. I can actually go do this in here. Y equals, so sine, that doesn't work that way. I want the sine of x, y2, I want sine inverse of x, and then go to graph. I'm going to zoom. Actually. Let's delete that and delete that. Alright, this should look a little bit better. So if you look, it technically kind of, if I were to draw the line y equals x, it mirrors about the line y equals x, which is a property we have from inverses, which was chapter 2. It was either chapter 1 or chapter 2. But it is a mirror image of our sine function. So just to recall our actual rules, so inverse rules. So if f is 1 to 1, then there is an inverse function. So that we don't have inverses unless there is an inverse function, well, unless it's 1 to 1. If I were to continue graphing this inverse function here, it would start going back upon itself, so then it would go over to there, and then it would continue, and now it would no longer pass the vertical line test. I'm actually going to go do that in red. Because essentially you're just taking your sine function and rotating it. So the inverse exists. Rule 2 is the domain of f is the range of f inverse. And then the range of f is the domain of f inverse. Rule 3 is f inverse sorry. So the f inverse graph is the reflection of f about y equals x. And then the last one that we're going to be using a little bit later, which is really important. This is actually part of our identities for this section, is that f inverse of f of x is just equal to x if x is in the domain of f. So what this means is if I had an angle, say 3 pi over 4, and I was trying to do f of 3 pi over 4, f inverse, I can't actually use this rule here because 3 pi over 4 is greater than pi over 2. So I'd have to find the reference angle for 3 pi over 4, which we're going to look at in a moment, so we'll worry about that when we get there. And then our last one is f of f inverse of x is equal to x if x is in the domain of f inverse. So I could not take, say, f inverse of 2 because, well, 2 isn't a coordinate on the unit circle, so I can't ever get this. It's impossible for me to take the f inverse of 2. It doesn't exist. Okay. Scroll over and leave that part there so we can still see that. Okay, when I work with these, I tend to care about my quadrants. So I have Q1, Q2, Q3, and Q4. Where would, say, an angle between 0 and pi over 2 fall?
Anywhere. Wait, pi over 2.
Yeah, so if I had, say, pi over 4, what quadrant would that be in?
So that'd just be first quadrant, right?
Yep, that'd be in quadrant 1. If I had negative pi over 4, where would that fall?
Quadrant 4.
Quadrant 4. Because instead of going counterclockwise, I would now be going clockwise. So this would be pi over 2, and this would be negative pi over 2. And this covers, so in quadrant 1, sine is positive, and in quadrant 4, sine is negative. So this covers all possible values, say on the graph of sine, because you can only have -1 to +1, and this covers all of those. So we can only ever work with angles that are in either quadrant 1 or quadrant 4 for sine inverse. Alright, only want angles in Q1 or Q4. Then there's just a little bit more notation, and then we're just going to do examples and we'll be done. In the book, this will either be written as sine inverse of x equals y, or it'll be written as y equals the arcsin of x. So saying sine inverse of x or the arcsin of x are the exact same thing. There's no difference. These are equivalent. So don't panic if the book has arcsin, just know it is the inverse function. Canvas size, I need to make this a little larger width-wise, so I'm going to go 78. That was not much larger. Okay. Inverse root 3 over 2. Sine inverse of negative a half. And then okay. I'm going to pull up, trying to think how to do this. So on the unit circle, which angle goes with root 3 over 2 in quadrant 1 or 4?
60 degrees.
Which is?
Pi over 3.
Pi over 3. And then what angle goes with negative a half?
Isn't it half over 2? No, that's wrong.
So you're looking for quadrant 4, because we know we can only work in quadrant 1 or 4. So we need to have a negative, right? So sine is going to be in quadrant 4 then. So what angle in quadrant 4 gives you negative a half for y?
11 pi over 6.
Yep, 11 pi over 6. And then negative root 3 over 2 would be
5 pi over 3.
Yeah, because that's one short of 6 pi over 3, which would be 2 pi. Good. Okay. So there's going to be examples in the homework, which is going to be on Friday. So Friday's going to have a similar layout as yesterday will be. I'm going to give you the homework problems, and then you're just going to try them, and then you can contact me during or through videos if need be, but it's essentially just the opposite method of finding a sine. The last thing we're going to look at, and I'm going to write this over here. So we had already mentioned this before with the properties that say f inverse f of x is equal to x if x is in the domain of f. So this is just applying it to the actual domains. So then we know that f inverse f of x is equal to x if, well, our domain for f is negative pi over 2 to pi over 2. So this is just taking something we already had in more linguistic terms and applying the actual domain values. And then f of f inverse of x is equal to x if negative 1 is less than or equal to x is less than or equal to 1. So if I were to give us sine inverse sine of, this should be sine inverse, not f. Should actually write this appropriately. So sine inverse of sine of root 2 over 2 so if we remember, pi over 2 is approximately 1.57. This is kind of helpful for doing a quick eyeball. Is root 2 over 2 between negative 1.57 and 1.57? So we know root 2 is actually less than 2. We know 2 over 2 is just equal to 1. So our answer for this is that yes, this is less than 1.57. We know it's positive, so it has to be greater than negative 1.57. So for here, our answer is just going to be root 2 over 2. Since it falls in the domain, we just take that as our answer. Oh, hold up. Huge error in my part. That should be sine, this should be sine inverse. In this case, sorry, that was a big mistake on my part. This still follows the same idea though, that 2 over 2 is equal to 1, and root 2 is less than 2. So then root 2 over 2 is less than 1. And then the last one, this one is sine inverse in front. So sine inverse should always have a coordinate, sine should always have an angle. I'm going to do 3 pi over 4. So for here is 3 pi over 4 between negative pi over 2 and pi over 2. The other question you could ask is, what quadrant is 3 pi over 4 in? And the answer is that it would fall in quadrant
Second
2.
quadrant.
Yep, second quadrant. So this is not in the domain. What is in the domain, and this is where we're going to have to start drawing or finding reference angles. If I were to draw quadrants 1 and 2, so I know this is positive. So this has to be an angle in quadrant 1. If I were to look at the unit circle, 3 pi over 4 gives me a positive root 2 over 2. The other angle that would give me positive root 2 over 2 would just be pi over 4. So this is where we kind of cheated to see what was what by like drawing lines and saying, oh, look, it lines up on the unit circle, therefore it has the same y value. So since they have the same y value, this is the reference angle. That's another way you could think about it. So this is actually just going to be pi over 4. So you can only ever get answers when dealing with sine inverse that are in quadrants 1 or quadrants 4 for sine. It's going to be different for cosine, it's going to be different for tangent, it's going to be different for cosecant and secant and cotangent. But for sine, we're only ever working with quadrants 1 and 4 because of
all students take chem, or whatever that is.
Exactly. But all students take calculus, all students take chemistry, whichever one you want to think about. And it also comes from this horizontal line test. I could be ridiculous and say that my domain is going to be from pi over 2 to 3 pi over 2. I could say that my domain will be from 3 pi over 2 to 2 pi. But it's best to include the 0. So if we include 0, we're going to be going from negative pi over 2, because that's where I'm at negative 1. I didn't label that as negative 1. And then to pi over 2, because that's where I'm at 1. So I'm covering all values in my range. And if I would take this piece, I won't fail the horizontal line test. So that's something we're going to keep doing with the other functions. We're going to keep using that horizontal line test to find their domains. And then essentially repeating these properties for the other functions, but we'll be doing that tomorrow.